Biomass, fossil fuels, and acid precipitation. In this lesson, we're talking about what is a biomass, biomass leading to fossil fuels, burning fossil fuels and the greenhouse effect, fuel from biomass, and then acid precipitation and pH.
Biomass. Biomass is biological material from living or previously living organisms. So, for example, mulch, wood chips, waste, plants, and animals. This material is usually recycled, broken down, and released, allowing the material to be reused. Sometimes, however, biomass gets trapped in places without oxygen. This is mostly plant material. Oxygen is needed to break down organic, living, or once living matter, so without oxygen, it can't be broken down. Over time, with pressure and heat, this trapped biomass is converted into things like fossil fuels, oil, coal, and gas. And that's what we're mining when we're taking things like oil and coal out of the ground. We're taking long, dead organic matter, and then we're going to refine it and use it for things like gasoline. Burning fossil fuels. The burning of fossil fuels is the world's leading method of producing energy. In this process, oxygen is used to produce energy and carbon dioxide. Now, it's a very easy means of producing energy. It's a quick and powerful means, so that's what we've been using for a really long time. Fossil fuels have been accumulating for billions of years. However, significant portions of the Earth's reserves have been burned by humans over the last 100 years. It's widely believed that the release of carbon dioxide is increasing the greenhouse effect, which is responsible for global warming. So it'd be something like this. Over about 4.5 billion years, we accumulated all our biomass, all our fossil fuels. And that's pretty much the time frame of Earth. That's about 4.5 billion years. And then in the last just few hundred years, so just a blink of an eye in terms of how long Earth's been around for, and then of a blink of an eye, we've depleted most of those reserves. If this is zero right here, we've used a significant portion in only a fraction of a time, a couple hundred years. And we still have all of this time, theoretically speaking, in front of us to use just a tiny bit that we have left. And this stuff takes billions of years to accumulate. So I'm sure you can imagine why we need to come up with a new method of producing energy. So just reverting back to the greenhouse effect. So what do I mean by that? Well, the greenhouse effect is when solar energy comes in from the sun here. It's going to hit the Earth, and it's going to bounce back as infrared heat. That's this number 2 right here. Sometimes this infrared heat goes out into the atmosphere, and sometimes it hits the atmosphere and then bounces back in. The more times it bounces back in, the more hot it is on Earth. So say more reflections equals higher temp on Earth. As we increase the number of greenhouse gases in the atmosphere, we're going to make this layer thicker. As this layer becomes thicker, we get more of this reflection happening. We get more reflections, higher Earth temperature, and that's going to lead to things like global warming and climate change. Fuel from biomass waste. There are 2 ways to get energy from biomass. Biomass can be burned to create heat to drive turbines, so that's similar to burning fossil fuels like coal. And the second way is by placing biomass into a tank alongside certain bacteria. The bacteria break down sugar found in the biomass waste in a process called fermentation. A product of fermentation is a gas called methane. This gas can then be collected and transported to a site where it can be burned to generate electricity. So if you're going to use biomass, but other biomass materials, you can use sawdust or plants that you grow as biomass. And then you can either burn them, like we have in number 1, or you can place them into a tank and allow the bacteria to produce methane, and then take this methane and burn the methane to produce energy. So I'd like you to pause the video and watch number 1, because it's going to overview this process. Biomass is considered renewable, as the source, so forests, algae, etc., can be replenished over a relatively short period of time. According to the U.S. Forest Service, wood is an abundant, sustainable, homegrown cellulosic resource that can significantly contribute to meeting 30% of the U.S. petroleum consumption from biomass sources by 2030, and help create a more sustainable energy future, improve environmental quality, and increase economic opportunities. If done correctly, fuel from biomass can meet a significant part of the world's energy requirements. Acid precipitation. So going back to fossil fuels, when fossil fuels are burned to produce energy, undesirable products can be released. We mentioned how they contribute to the greenhouse effect, but they're also going to release other things like nitrous oxides, NOx. This X can be 2, 3, etc. It's going to be a variable that can be substituted in for a different number later on. And sulfur dioxide, SO2. These 2 things can be released and combined with water, so H2O in the atmosphere, to form acids, mainly nitric acid and sulfuric acid, HNO3 and H2SO4 respectively. These acids then fall to Earth as acid precipitation in the form of rain, sleet, or snow. So things like factories are going to release our NO2 and our SO2. That's going to combine with the water in the clouds and in the air, and that's going to form our acids, nitric and sulfuric acid. Those acids are going to fall down to Earth as acid precipitation, and you can see that right here. When we're talking about acid precipitation, we need to mention pH. pH is a measure of how acidic a substance is. Acid examples include things like sulfuric acid, citric acid, we just talked about nitric acid, and it's measured on a pH scale from 0 to 14. 7 is neutral, and that's going to be your water and blood. 3 is acidic, things like vinegar, and 12 is going to be basic, ammonia, household cleaner, etc. Anything to the right in this chart from 7 is going to be basic, and anything to the left, so less than 7, is going to be considered acidic. So what are the effects of acid precipitation? It can deplete the nutrients from soil, killing plant life. It can cause numerous problems in aquatic ecosystems, killing fish, amphibians, and other organisms due to the decrease in pH. Organisms can only live in a certain range of pH. If you force them to live outside that tolerance range, they're not going to survive. And lastly, it can also destroy stonework. So stonework is generally made from things like limestone, which gets dissolved by acids. And lastly, we have ocean acidification. When carbon dioxide dissolves in the ocean, it becomes carbonic acid, which decreases ocean pH levels. So carbon dioxide is in the air. When it goes into the oceans, it doesn't stay as carbon dioxide. It changes. It changes into carbonic acid. So we're going to combine the CO2 from the air with the H2O in the water, and that's going to give us H2CO3, and that's carbonic acid. So the more carbon dioxide we have in the atmosphere, the more carbonic acid we're going to make. The more carbonic acid we make, the lower the pH of the ocean and lakes become. The acidity of the oceans has increased by 26% since about 1850. A decrease in pH will also have a significant impact on marine ecosystems. A decrease in ocean pH can make it difficult for marine calcifying organisms, such as coral and some plankton, to form shells and skeletons. If they can't form the shells and skeletons properly, then they're going to be weaker and they're going to die quicker and more easily. If these organisms die, that's going to extend up the food chain to affect economic activities such as fisheries, agriculture, and tourism. So how do we reduce acid precipitation? Well, we can reduce it by reducing the amount of fossil fuels used, using alternative fuel sources like biomass, like solar, like wind, improving technologies to prevent the harmful gases from escaping into the air, and improving standards for factories and motor vehicle emissions. And that concludes our lesson on biomass and fossil fuels.